Welcome to The Explainer. Today, we are decoding the secret language that decides if your favorite apps run like a dream or grind to a painful halt. And trust me, once you understand these core ideas, you'll never look at the software on your phone or computer the same way again.
So let's start with a feeling we all know a little too well. You're right in the middle of something, typing a message, scrolling your feed, and boom, the app just freezes. You get that dreaded spinning wheel of doom. What is actually happening under the hood?
Well, the answer lies in these four terms: synchronous, asynchronous, concurrency, and parallelism. Now, these are some of the most misunderstood concepts in technology, but they explain everything. So let's dive in and uncover the four surprising truths about how software really works.
Okay, first things first. We have to tackle the biggest point of confusion right out of the gate. Concurrency and parallelism are not the same thing. I know, they sound similar, but they describe two totally different ways of getting things done.
The real secret is in the wording here. It's a subtle change, but it's crucial. Concurrency is about dealing with many things at once, kind of like juggling. Parallelism, on the other hand, is about doing many things at once at the exact same time.
To make this super clear, think of a single chef in a busy kitchen. He's chopping vegetables, then he quickly turns to stir a pot, then he checks the oven. See? No two tasks are happening at the very same instant, but progress is being made on all of them. It creates this brilliant illusion of multitasking. That's concurrency.
Now, parallelism is what happens when you bring in a second chef. One chef is 100% focused on chopping veggies, while the other is totally dedicated to cooking the meat. The work is truly happening at the same time because you have more resources. In this case, you've got more chefs.
So, why does this matter to you? Well, concurrency is the magic that keeps your apps from freezing up. It's what lets the user interface stay responsive even when it's busy. Parallelism, that's the raw horsepower you need for the really heavy jobs, like rendering a video or crunching a ton of data.
Okay, let's move on to our second surprising truth. It turns out that our super powerful, lightning-fast computers spend a shocking amount of time just sitting around doing absolutely nothing.
This is something called blocking. You see, when your app needs to do something slow, like read a file from the hard drive, the main brain of your computer, the CPU, just stops. It literally sits there and waits for the much slower hard drive to find that file.
As expert Hussein Nasser puts it, this is just a massive waste of resources. The whole program is basically held hostage by one slow operation. And if that's happening on the main part of the program, well, that's when your whole app freezes.
So what's the solution? It's something called asynchronous programming. Instead of just waiting, the program sends out its request and basically says, hey, just call me back when you're done. This frees it up to go do other useful work, which keeps the whole application running smoothly. It is absolutely essential for modern software.
Okay, so if one path of execution, what we call a thread, can get blocked, the obvious solution is to just add more threads, right? Just do more things in parallel. Well, our third truth is that this simple-sounding idea is actually incredibly dangerous.
That's a really strong statement from Hussein Nasser, right? Calling it a crime. But it points to a very deep, very difficult problem. The moment you have multiple threads all trying to access and change the same bits of memory, you can end up with total chaos if you're not super careful. This leads to developer nightmares, like race conditions. That's where two threads literally race each other to change the same piece of data, and whoever gets there last messes everything up. The fix is something called locking, but that can create its own traffic jams and is just notoriously hard to get right.
And you can see why right here. Multithreading is complex and has a high risk of errors. That's why many modern systems prefer other options. Multiprocessing gives each task its own private memory, so they can't mess with each other. And asynchronous programming, it cleverly avoids the sharing problem altogether, making it way less likely to cause these kinds of bugs.
All right, for our fourth and final truth, we're going to tie all of this together with a really simple story. All you need to remember is eating cake and singing a song.
So the synchronous way is super simple. You do one thing and one thing only. You eat the entire cake. Then, only after the cake is completely gone, you sing the entire song. One task after the other, no overlap.
Now, the concurrent way is like one person switching back and forth. You take a bite of cake, then you sing a line of the song. Take another bite, sing another line. You keep switching until both the cake and the song are finished. You're making progress on both, just not at the same time. And finally, the parallel way.
This is when you bring in a friend. You eat the cake while your friend sings the song. Two separate things are happening at the exact same time because you have two people, two resources working at once. Simple as that.
So after all that, what are the big secrets you've unlocked about the software you use every single day? What should you take away from this?
Okay, let's break it down. 1. Remember, concurrency is about dealing with tasks, creating that illusion of multitasking, while parallelism is about actually doing them at the same time. 2. That synchronous waiting we talked about, it's a huge, massive waste of your computer's potential. 3. Just adding more threads might seem like an easy fix, but it's a very powerful and very dangerous tool. And 4, hey, sometimes a simple story is all you need to understand a really complex idea.
So the next time your app stutters or freezes up on you, you'll actually have a pretty good idea of what might be happening. You can ask yourself, is it just stuck in the synchronous line waiting for something slow? Or maybe, just maybe, it's caught in the chaotic dance of a multi-threaded bug. The magic and its little flaws are no longer a secret. Thanks for watching.